Okay, so the next part of this presentation is about COALA in a nutshell. So I will talk about the project itself and what it means, what it is about, and where we are in the process of going through the project also. The project itself is a research and innovation action funded by the European Union, and it's roughly about 6 million in total costs. We started in 2020 and the project will end in 2023. So right now we are in the middle, as you can anticipate from these numbers, and the webinar is about presenting the state up to month 18, so the middle of the project exactly. The consortium in COALA has partners in 4 areas. The first area is the research and technology development and education part, so universities and institutes that do the research work in different disciplines also. Then we have solution providers that help us build the software, extend the software, deploy it also at the end users' premises, so in factories, in fact. And the end users are 3 in total. I will go into a bit of a detail there later in this presentation. And the last part is then partners for innovation management, and those are helping us transfer the results to exploitable or marketable products in the end. COALA's vision is for an AI in manufacturing, and by AI we mean an AI which is proactive and pragmatic. It helps people, it supports them in operative situations that are typically characterized by high cognitive load, by time pressure when you're working, and little or zero tolerance for quality issues. So in the end, it's an approach of human-centered AI or human-centered digital assistance in this case. And one of our visions is also that we are going to shape the complementarity between AI and humans at work. So the AI is good at doing things that are time-consuming, stressful, and it hopefully can do that in a reliable and credible way, while the human focuses on things that require more understanding because they are complex, there's a lot of context to understand, and problem solving, and that's typically the case in complex and knowledge-intensive situations. Besides the technology part, we also have parts which deal with education and training, so teaching workers the capabilities of a digital assistant, for instance, but also about the risks involved in the technology and the limitations. In some cases, this is a bit broader, so covering AI in manufacturing rather than the assistant in a narrow sense. The next slide is about the COALA solution. So this is about what we are building, and the most obvious part is that we are trying to build a tool that helps workers getting through cognitive work. So when they have to think a lot, or when they need to process information themselves that they need to get first also, then this is done by our solution, and it's built from trustworthy AI components. So trustworthy in this sense means that we are sticking to ethical requirements, so we try to meet these requirements, and we're trying to be transparent also how the AI works, and providing some level of explainability of AI behavior also. The solution in the narrow sense is then our voice-enabled digital intelligent assistant. Voice-enabled means that we can talk to it by voice, so that is one of the key characteristics. The solution will support workers who need to use analytics tools, data analytics tools in manufacturing situations, and there's a large focus also on new workers and helping the new workers to get through on-the-job training, so speeding up that process in some way. And of course, the education and training concept that that the consortium will build, which focuses on teaching blue-collar workers competencies in human AI collaboration. This is an overview about the project. This is essentially the project in a nutshell. So starting from the objectives and ending with the expected impacts that we are trying to achieve here. So we have 4 objectives roughly related to 2 aspects of manufacturing. That's product and process quality that we are trying to improve, and agility in the production. That agility means that we are able to introduce new workers faster into the work, so they can become productive faster, sooner than it's the case today. And objectives 3 and 4, they concern the human AI collaboration adoption. So embracing and adopting AI in manufacturing in different ways. In the most obvious way, it's talking to an assistant that's not human, so it's an AI. So that would be a big achievement also if we can get acceptance for that. We have 1 work package done right now, which is our augmented prescriptive quality analytics for factory workers, and that is also presented later in these slides here, or in a later part of the webinar. And that concerns different enablers that we managed to work out so far, and that are like largely integrated also, so they work as one piece. And then there are 2 other work packages that are ongoing. That's the smartening of workers with AI competencies and the AI assisted on-the-job training. So the training concept part and the part which helps workers get faster into work. So passing through the training process faster in principle. And also the adoption and evaluation, of course, so going into the real factories and then doing experiments there, finding if the solution is helpful. Technically, I don't want to go so much into detail. Our assistant is accessible via mobile devices. It is a multimodal interface, or allows multimodal interactions. That means beside natural language, spoken and written, we also support screen interactions with a touch screen in this case. So that is an aspect. And then in the background, there are AI-based components that allow the assistant to be smart, intelligent in some way. And this then concerns 3 parts: prescriptive analytics, cognitive advisor, and explainable AI component. The solution is largely built based on open source technology. So we use Mycroft, the open source digital voice assistant, and we use Rasa, which is a chatbot framework, and both of them, they communicate in our solution and build the one assistant that you are talking to as a user. You won't perceive that there are different assistants in the background actually. This is the last slide about the business cases. So we have 3 business cases in textile production, white goods, and detergent production. They are very different. They pose very different environments. Manufacturing environments have different requirements. 2 of them, so textile and detergent production, they focus on worker training and introducing new workers faster into the work process. And the white goods case focuses on predictive quality and using an assistant in that context. So that will be a part of the presentations that come a bit later after this more general overview. Good, so this is the last part for this, and now I will switch to my second presentation, which is about applying digital intelligent assistance in manufacturing. So this is starting here with the general idea of what we see a digital assistant is. So it has 4 kinds of characteristics or aspects that we think is special, or is making up this this concept of digital intelligent assistant. And that's, first of all, that it interacts through natural language, so spoken or written natural language, and that gives you the possibility to have conversations with the artificial intelligence. The assistant also supports or takes over time-consuming, stressful, or other unwanted activities. So it's helping humans rather than replacing them. That's a very different, a very important, actually, differentiation from other kinds of AI tools used in manufacturing. So support. And then the assistant knows and does things that humans associate with intelligence. So this is our understanding what the intelligent assistant makes up. So it's intelligent because humans perceive it as intelligent. If you look into the back end, the background technologies, the rules that we apply, then it's not so intelligent in some cases, but that's not the definition that we have here. It's about what the users perceive as intelligent. Then the last point is that this technology, or this assistant, is an amorphous compound technology. Amorphous means that it can be useful in many ways. That depends on what kind of skills or what kind of apps you load into the assistant. So depending on what you have there, it can be good for one case or another, and it's generally difficult to pinpoint its unique application area when it's actually a very flexible tool to use, like smartphones, for instance. The compound technology aspect is relevant because in order to have a digital assistant, you need to put together a lot of different technologies, and they need to work together seamlessly. So to give you a good user experience and the impression that that you are dealing with one tool in the end. I want to say a little bit also about factories as workplaces. So here are some illustrations from the factories of our project partners. And as you can see, they are quite different. So we have some areas which are very narrow, and working there is very, you don't have much space to work there. At the same time, we have areas which are very wide. So you have to walk long distances to reach from one point of a factory to another one. It's noisy, obviously, so a lot of noise and different kinds of noise, also from like humming in the background to noise where you need to wear ear shells also to protect yourself. There's manual labor, so manual work to do, and there's also automated work, so where machines take over a lot of the actions, and there's a mix of them usually in factories. And increasingly then, of course, we have robots or collaborative robots, so-called cobots, now in factories that are a different kind of artificial intelligence in manufacturing. Now I want to present a little bit about benefits that digital assistants provide in manufacturing environments. For that, I have these slides now that on the left-hand side cover a challenge in manufacturing. In the middle, you see an illustration, an animated illustration of how an assistant could help out in order to address the challenge. And on the right-hand side, you see a general overview of different benefits, independent benefits also, that an assistant provides for manufacturing. Not only for manufacturing, can be also benefits in other areas, but in this case we looked closer at manufacturing, and that's from a paper that we published last year. So in this case, you see that in manufacturing environments, we have costly vocational and on-the-job training that takes days, weeks, or years sometimes until a worker is fully able to meet the performance that is required on a daily basis. And in that process, they can receive benefits. They can receive learning contents when they are new. Then they can ask questions to the assistant, and the assistant provides them some material to support self-learning somehow. So the workers can understand things better. They can ask for individual support. So it's not necessary to have an expert or a senior worker standing next to them all the time, because that would be costly and is not generally doable also in many production lines. Then we have the aspect of continuous learning. So every new worker at some point will become a senior worker when they are long enough in the job. And this transition we need to consider also with the assistants. So these users start as novices, then they are intermediates, and then they are experts at some point of time. And they need different kinds of assistance. So for a novice, asking for instructions, for instance, asking for help might need to be more granular, need to provide more details. While for an expert, you need to have your information quickly and to the point. You know a lot of things, so you can guess some things from your experience that the assistant doesn't have to make so explicit then. So this is illustrated here in the example also, where we see a checklist that the user asks about, and then the assistant provides some support to that. And an expert would need less details about each step, so the list can be more doesn't have to cover so many points in principle. You will see that later in one of the other presentations also. And then another aspect is costly shift systems. So to address fatigue and recreation of workers, obviously, an assistant doesn't sleep, so they don't need to recover. So they are available all the time when humans need support. Then they work and they can provide that support. Maybe it's not as good as a human support in many areas, but still it's there and can help out in one or the other situation that might arise on a daily basis. One of the most obvious maybe aspects of benefits is that in information-intensive tasks, when you need to interact with a lot of IT systems or software in your organization to get everything together, then the assistant can serve as a central access point. So it is connected to different information systems and can help you get information through the single interface that you have when you talk to the assistant. So you don't need to jump from one interface to the other, need to learn how to use them. So you use your language ideally to ask for information. And then another aspect is that you can have different devices where the assistant is either installed into or is accessible through, and that can be a stationary device, a mobile device, and they can have screen only, voice only, or something in the middle. And when you have voice only interfaces, or interfaces with a strong voice component, then these are very useful if you want to work eyes-free and hands-free. So this is sometimes the case when you work with machinery in a production, then you need to use your eyes on something and also the hands, then you cannot interact with the screen, for instance. So you need to use your voice only. That's difficult sometimes because you cannot convey all kinds of information through language, so through natural language in particular, and that makes it a bit difficult, and we are trying to find the boundaries for what works and what does not work in manufacturing environments also. The last point is then some kind of advertisement. So if you're interested in digital intelligent assistants, and in particular in manufacturing, then we are building up a kind of task force, a group of an open group of experts that are interested in digital assistants, conversational AI, soft bots, and other related topics in manufacturing, and we're going to talk about technological barriers and ways how to remove them, and also the operationalization of AI ethics, because AI ethics is an increasingly important requirement of AI, that it doesn't behave in a way that is not considered as ethical. And the European Union has a framework for ethics, AI ethics, by now. So there are some guidelines, some rules that you need to keep in mind when you build or work with AI. So this is something that we need to discuss and want to discuss in this task force too. Thank you. This is everything. This is the last slide. So I have nothing else to present, and I will give now my floor to the next speaker.